So, let us start with a very basic geometric problem that you are given a set of n objects, and those set of n objects are modeled as some polygons like you can see in the slide, and the objective is to find all the intersection points of these objects. So, there are many applications of this problem. For example, consider a set of robots which are moving in a floor of a room. Now, they move in a straight line. So, their path will form a curve consisting of several straight lines. There are n robots and you want to find out whether there will be a collision between any two robots or not. This is your task. There can be many such examples, and our objective is to solve this problem. But say we are not able to solve this problem. So, how do we do research? When we see a problem, first we try to go to the deep of this problem, that where the complexity of the problem lies. This is the outlook of the problem. But if you think of this problem in little bit more details, you will find that the basic structure in this problem is the following problem, where we are given a set of n lines, just simple n lines, nothing else, and we would like to calculate the intersection point of all such lines, or I should say that it is not lines, but the line segments. They are given a set of n line segments. Two line segments may intersect or may not intersect, and we would like to calculate all the intersection points of this n line segments. Are we good? Is the problem clear? In the session just after the lunch, the first problem is to have to make the problem clear, because otherwise after 5 minutes everyone starts to sleep. Just raise your hand if the problem is not clear. Simple problem, right? First question, can you let me know an algorithm to solve this problem? Any algorithm will go. We will compare each pair of lines and see whether they are whether they do an intersect or not, right? How many pairs of lines possible? N choose 2, that is for computer scientists it is n square, right? This is the best, this is a naive way to solve this problem, that I am given a set of n line segment and find out all the intersections. What I will do, I will pick any two pairs and see whether they will intersect or not. The total choice for pair is NC2, that is order n square. So, in order n square time I can solve this problem, correct? I hope that you know that how to find given two lines, how to find the intersection points, or given two line segment, how to find out the intersection of these two lines. Any two lines intersect if they are not parallel. I am assuming that none of the lines are parallel, but when you are talking about line segments, they may intersect or may not intersect, and this is basic geometry to find out whether they have intersected or not. Clear? Naive, no difficulty. So, this is the algorithm that we are doing. Questions? Questions? Easy problem, easy solution, right? First question, can you improve this algorithm? This is possible to improve this Is it possible to beat this bound of n square? How many of you think that yes it is? Raise your hand please. Please raise your hand if you think that it is possible to beat this n square bound, right? Why otherwise I am asking this question? Common sense. But the funny thing about a common sense is they may not necessarily true always. So, in this example there are n by 2 horizontal line segments and n by 2 vertical line segments. What is the number of intersections? N by 2 into n by 2, that is for a computer scientist this is order n square, checkmate. So, if you have to report order n square time, or if you have to report order n square intersection points, there is no hope for giving a better algorithm. You have to report at least order n square time, and to report one intersection you will take at least order 1 time. So, order n square time gone. Give it to me. Clear? But when I say that the runtime is order n square, because our mind is tuned to think in that way that the runtime of an algorithm has to be measured with the size of the input. Right? That is how we are taught, right? Right? But is it necessary that we have to measure the runtime of the algorithm in terms of input size? What if the given line segments intersects in a constant many, there are constant many intersection between the given set of line segment? Possible. But in the previous algorithm, how much time we will spend? Still we will spend order n square time, although the actual intersections that we have to report is constant or maybe linear in n. It is possible. Clear?
Order of n square algorithm and this problem are the same. Are the same. This is n by 2, n by 2.
Yes.
So that geometric way how they are intersected. Here these intersections are the same problem.
Yes. Same problem. This is one instance of the problem that we want to solve. Suppose I give you this instance, then whatever algorithm you give me, that is how we calculate the lower bound of algorithm. So, whatever algorithm you give me, for this instance, your algorithm has to spend order n square time, right? So, you cannot beat order n square time algorithm in any way, because you have to report order n square time for this instance, right? My point is, but in some cases the number of intersection may be much smaller than order n square, but this algorithm even for that instance will spend order n square time, because what it will do, it will take any two line segments and check whether they will intersect or not. That does not make sense in some way. Do you agree with me? Now I modify my question a little bit and ask you that is it possible to find out an algorithm or device algorithm whose running time will not only depend on the input size, but also this running time will be a function of input as well as output size. More specifically, can we design an algorithm which will take time, which will find out, of course correctly find out all the intersections in time n log n plus k, where k is the size of the output that you have to report. When k is order n, our algorithm will run in n log n time. This is the ideal that we want to achieve, and this is certainly possible. But today I am going to discuss a solution strategy which will not achieve n log n plus k, but that will achieve n plus k log n. Okay. One point I want to make here at this point, when n is linear, when k is linear on n, this is n log n, but k can be n square. At that time this algorithm will take n square log n time slower than the previous algorithm. Previous algorithm was taking, for you take any input, it will take n square, but this algorithm in worst case can take n square log n time, but the hope is that we will not get that a skewed kind of a instances a lot, and we expect that the number of intersections is kind of linear. So, our algorithm will outperform the naive algorithm. Please raise your hand if you have any doubts. Runtime will depend, I want to devise algorithm such that the runtime will not only depend on input size as well as output size. Everyone okay? Very nice. But again, when we are trying to solve a problem and we can't, what we do to write papers or to publish results, okay, we can't solve this problem, make it simpler and try to solve that problem, and that is how you should think about. While solving a simpler problem, you might get some insight about the difficult problem, and that might help you in solving the difficult problem. The problem we have started with is a set of n lines in a two-dimensional space, but let us start our discussion with a much easier problem where you are given a set of intervals in the real line. These are all this is not two-dimensional data, this is one-dimensional data. These are all intervals, but if I draw them one after the other, you will not be able to understand that which interval is which. That is why this is drawn in this way. These are all intervals on the real line. Right? Now we ask the same question. I would like to find all the intersections of this line segments. Clear? Are you in the same page? That can we solve this problem in say n log n plus k or n plus k log n? Can we do that? Trivial is n square. How to solve this? Very good, very good. So, we will do what is known as a sweep line technique. What does it mean? I will slide a line from left to right and keep track of the intervals whose left endpoint is left of this line and the right endpoint is the right of this line, the sweep line, and if at this point I encounter a new line segment, I know that the new line segment will intersect all the line segments which are so called active till now. What do we mean by active? This is just I am sweeping a line from left to right. At any given point, this line will intersect few line segments. Those are the set of active lines, right? Right. For example, in this here, what I will do? First, I will encounter the left end point of S1. I am sweeping. Think about this. This is a thought experiment. Then I will encounter the left end point of S2. Which are the two active line segments now? S1 and S2. So while I will start S2, what is the active line segment? S1. Right? So S2 must intersect S1. There is a non-empty intersection. Right? Then what intersection what point I will encounter? Is the left end point of S3. I know that S1 has started, S2 has started, but none of them has finished. So S3 must intersect S1 and S2. Then which end point I will find out? End point, right end point of S1. Right? So I will delete, it is no longer an active line segment. Right end point of S2, it is no longer an active line segment. Then I will encounter the left end point of S4. But what is the line segment that is active now? S3. So S4 must intersect S3. I will report that. This is the overall scheme that I am going to follow. Is it clear to everyone? Just I am doing a thought experiment and sweeping a line from left to right. Right? But can we move a line segment continuously from left to right in a computationally domain? Well, computationally speaking, can we do that? No, right? We can move the line in certain discrete points. They will calculate at this point, then this point, then next point. I have to go on like this. That is how computer thinks, right? So I have to first calculate at certain points while doing from left to right, scanning from left to right, and I will stop at certain points, and I will recalculate the information and I will move ahead. It is like setting up an alarm. What I am doing, I am moving in a real line continuously, and I am setting up at alarm that I have to stop at x1. Then next I stop at x1, I have to do something, make some changes. Next I will stop at x2. Right? This is how we work. So the points at which I will stop is known as event points or events. Question to you. What are the event points here? Where I have to stop? Very good. Then how many events will be there for this problem? 2n, right? When I am starting the problem, what I have is a set of line segments. That means I have the endpoints. So beginning of the algorithm, I know what are my event points are. Clear? Right? I know that I have to stop at exactly at these points. So stop at the left end point of S1, then left end point of S2, like this. And I am saying that I have to maintain certain information while moving. What are the information that we are maintaining here? intervals at this current point. At minus infinity, what are the active event points? None, no active line segments, right? At the left end point of S1, S1 becomes active, right? Clear? So, this is my overall idea. But how to execute? Use your common sense. How do I know that which event point comes after which? Sort, right? I have to sort all the event points from left to right, and then accordingly I can stop at different endpoints. What about the status? So, I need the event points and I need the status. Status means the set of active line segments. How to maintain them? Array? How to maintain? Stack. Okay, one idea is stack, very good. Any other ideas? Queue, stack, queue, linked list, anyone? Basic data structure will cover, don't worry. Why, what's the problem with array? Why not array? Okay, what about insertions? We don't have to worry about them. So, how much time a insertion in a stack takes? N, can be order n. Because I have to look for which element where to insert. So, insertion say order 1. What about deletion? I have to delete a particular element, not at the top of the stack. Order of n. How many event points? N. फायदा क्या हुआ? Nothing. N into n, n square. We are spending order n square time. So, looking for something which has to be sublinear. What is the way to store n objects so that any deletion and insertion can be done in a sublinear time? Which tree? Balanced binary tree. Balanced binary, it has to be balanced, but there are self-balancing binary trees which can do all the insertion, deletion, update, everything in log n time. For example, heap, whatever, and use any balanced binary search tree. That should work, right? Are we good? So, what I will do? I will store all the active line segments in a balanced binary tree, and when I reach a right endpoint of that line segment, I look for it and delete it, and I know that all this operation can be done in log n time. How much time altogether? N log n. 2 n event points, log n each. Okay. So, at least we have learned how to solve the problem in one dimensional space. This is the overall idea, that is what we are doing. But where is the report time goes? So, when I am inserting a line segment, I have to report all the active line segments, but that I can charge on the output size k, because when I am reporting, there must be an intersection. So, I have two components. In my ideal situation, I have two components. One is n log n and another is k. What is k? K is the output size. So, here I am doing a charging argument. Few operations I am charging on the n log n part and few operation I am charging on this k part. Whenever I report a intersection between two line segments, I am charging that on k. Plus how many times I will report an intersection? Only once, right? And if I am not reporting anything, how many operations we are doing in each insert and delete? Constant many. Any doubts? Please raise your hand. It's okay. It's perfectly okay to have doubts. What I am doing when I am see this S1, I insert it. There is nothing else to report. When I am reach at the left endpoint of S2, I do two things, two operations. One is insert S2 into the active set of lines and to report the intersection of S1, S2, right? I will calculate this reporting time in my right hand side and insert time in the left hand side and sum them both at the end. If I sum at the end, each intersection I am reporting only once, so that will be k, and each insert it takes log n amount of time. There are n insert and n delete, 2 n log n amount of time, plus in the right hand side I have k. So, all together this is n log n plus k. Clear? If you have any doubt, let me know. Okay? Is it clear? If it is not clear, let me know, because the next problem, that is two dimensional, more difficult problem, that is why you have to do it. So, faculty always has this privilege to solve easy problems and keep the difficult problems for homework, right? So, I have that privilege. So, it is a right time to let me know if you have not understood this, the solution of this problem. Say I have a structure, basic tree language, the structure line which has a left endpoint, which has a right endpoint.
How are we sorting that?
Left endpoint, right endpoint.
So we are sorting the lines exactly.
Yes. Oh no, we are sorting the endpoints, because each endpoint is a
So we take
inter.
endpoints and then sort them.
Yes.
So we are really sorting the lines according to the endpoints, but the endpoints separately.
Yes, because those are the endpoints.
And then when we reach some endpoint,
But then I will put a pointer from this endpoint to the actual line segment. This small data structure jumbles that it's possible to do. Instead of keeping just an integer number, I can keep a structure which is an integer number and a pointer to the actual line segment. Yes, sir. No. No, what I am doing, when I encounter say left endpoint of S5, I know that the active lines are S4 and S3. I will only report the intersection with S5 with S4 and S3, not with everyone else. Why should I do that? Because S5 is not intersecting with S1. Why should I report a null for them? If I want to do that, that will take order n square time. I cannot escape that. Yes. Yes. No. Yes, but then I will charge it to n log n. I have n log n. I add, okay, if I make it n plus k, reporting is n plus k. Does it going to change anything? Because what is n log n plus n? This is order n log n. Right? So you rightly pointed out, technically speaking, I am spending at most n plus k time to report. If all the line segments are disjoint, number of intersections is 0, but I am spending time order n for reporting, but I will not report anything in that case because there is no active, but I will say I will spend something, but I do not care. Because what is n log n plus k in terms of order? It is still order n log n plus k. What is order n log n plus n? Do you know asymptotic notations? So, what is n log n plus n? In order notation, order of n log n plus n is order n log n. This is funny, if you are not, no, what I am saying is, this is order n log n. Okay? This is, you go back and study, this is basic of asymptotic, because you are not maybe familiar with this, that is why it seems strange to you. But there are a lot of things we are hiding behind this order O. Okay? Now, let us move on. So, we have reached to the two-dimensional problem. We are given a set of n line segments and we would like to find out all the intersection of those line segments. How to do that?
Project the corresponding interval on the x-axis,
Mm-hmm.
then sort
Mm-hmm.
end point of each interval, then make shifting algorithm.
Okay, very nice. What you are suggesting is that I will project this here, maybe here, then here, right? So, I will get some intervals and then find out the intersection. How much time it will take? N log n plus k. But it may so happen that their x coordinate overlap, but there is no intersection at all. That is certainly possible, right? If I have a line,
Just give an example where they are not intersecting.
here, this is the example. Can you see this? Good idea. Come back to this idea in a later stage of the class, maybe third or fourth class, we will come back to this idea, very good idea. But we may spend order k time here, but k signifies nothing.
K is 0 here.
K is 0 here, right? Then what to do? Think. I cannot think for yourself. happens if I use the same idea? What I was sweeping? A line from left to right?
Vertical. Top to bottom.
Doesn't matter. Left to right, top to bottom, doesn't matter. We'll see what to maintain.
They are not intersecting.
No, what I will maintain is, this is my sweep line, right? I can sweep a line. No one can stop me, right? My question to you is, what will be the sweep line we can do, but whether that will give you a result or not, that's a different question. But we can sweep a line. No one can stop me. First question, what is the event point? My idea is I will sweep from left to right. First I encounter the left end point of L1, then left end point of L3, left end point of L2, then L3, then L4. I do not know whether they will intersect or not, but I will encounter them. This is the order in which I will encounter. So, what will be the event points where I have to stop? Endpoints of the line segment, that I need to maintain, right? Right, at the end, because if I do not stop at the start left end point of a line segment, no way I will know that there is a line segment that has started, right? Are you with me till now? Let me know.
Even say if two lines do not intersect,
Hmm.
so maintaining left and right end points of each line, in which way it is going to help me?
We'll see, we'll see, we'll see. But I can certainly start scanning from left to right, and I will stop at the endpoints. So, what I will do, what is trivially that I can do when I encounter a line? Suppose I am sweeping, I encounter L1. I will do the same thing that I was doing. I will check whether, suppose I encounter the left end point of L3. What are the active lines? L1 and L2. I will check whether it intersects with L1 or L2 or not. I will check. No one can stop me. If they intersect, I will report, otherwise I will not report. This is one thing that I can do, certainly. Do you agree? But there is a problem if I do that. What is the problem? First, then I will check intersection with the line before it, one line, then there will be third intersecting with two lines, three lines. I will spend n square time, 1 plus 2 plus 3 plus 4 plus n. No hope, right? How to overcome this? So I cannot, at the beginning, I cannot find out which line segments, the new line segment will intersect eventually. I cannot do that. That will, then I will lose all the times I have, and it will eventually give me a order n square time algorithm. Is it clear to everyone? That I cannot, when a line segment is introduced, I cannot look for all the intersection points, whether it is intersecting with all the line segments, right? Right? Very nice. consider maybe a when the swift line reaches the left point of L5. Right. Okay, so before that even I would like to, I would want you to think about something. Suppose two line segments intersect at some point. Can we always claim that? So, for example, at this point L4 and L1 intersects, right? If I just look epsilon amount left to this event point, L4 and L1 has to be adjacent to each other. What I am looking at the sorted order of the lines. So, what is order? This is L3, then we have L1, then we have L4, like this. In this ordering, I can order the lines along the sweep line. Here they intersect, but just epsilon left to this point, they have to adjacent to each other if they intersect. So, just before the intersection of any line segment, they have to be adjacent to each other. Is it clear? Is it clear? Right?
So, but what if say L1 ends and L2 starts the point of where the L1 ends, so at that point they decontinue.
So, you are saying something like this?
Yeah, I mean like if they are intersecting at the end point.
Okay, very good, very good. That means you are thinking. Adjacency not necessarily implies they will intersect. Intersect implies adjacency, right? Right?
If they intersect, then must be adjacent. Adjacent
Does not imply intersection, right? So, I am assuming that no three lines intersect at the same point. I am assuming that. Let us try to solve a simple case. We can handle that even. Yes, same question. Okay, assume that no three lines are intersecting at the same point. Okay. So, what is my idea? I will scan the input from left to right, and what I will maintain? What is the status that I would like to maintain? Not the active line, not only the active lines, order of the lines along this sweep line, right? Right? I assume there is no vertical. I will tilt my axis. I can always tilt my axis epsilon amount so that there is no vertical or horizontal line. Okay? Okay. So, okay, now what is the status that I want to maintain? Is the sorted order of the lines along the sweep line. When the status can change? left endpoint, because new line will be introduced somewhere, right endpoint, right, and intersection. At that time what will happen? They will switch, the order will switch, right. So, what is my idea? How I will save time? I will not calculate intersection at to the all the line segments when there is a change in the ordering. I will calculate a possible intersection at that time, right. What do I mean? I have L1 left endpoint, nothing to check. L2, what is ordering? L1 then L2. I will check whether L2 intersects with L1 or not. Yes, I will put it in the event queue. Next L3, what is ordering now? L1, L3, L2. Right? So, L3 needs to be checked with whom? Who are the adjacent now? L1 and L2. Right? I will check whether L3 intersects with L2, yes or no? Yes. L3 intersects L2, right? But does L3 intersect with L1? No. So, I will not insert into the event queue. I will not check whether L3 intersects anyone else or not, right. I will, next event point is the intersection of L3 and L2, right. Now, L2 will, what is ordering after this? L1, L2, L3. So, what I need to do? Previously it was L1, then L3, then L2. Now it become L1, L2, L3. So, who are the new neighbors? L1 and, right? Because previously L1 was here, L3, L2 was here. They are not adjacent. Right? I will check that L1, L2 intersecting or not. I will insert the event point if it is not already being inserted, okay, and so on. So, let us see what we are doing. In a left endpoint, what we are doing? Inserting a line segment in a sorted tree or balanced binary search tree. What else we are doing? We are inserting in this order in a particular place. So, we have so L6 will be inserted in between L4 and L3 in the figure. With whom I will check intersection? Whether L6 intersects with L4? Yes. No, it is not intersecting. Does L6 intersect with L3? No, it is not intersecting. So, there is no intersection, right. If there is any, we will do that. At right endpoint, I do not have to do anything, just delete that from the balanced binary tree, right. In the exchange, the order will change. How many pairs I have to check? How many new pairs will be generated? Look at here. Li, Lj was previously neighbors, now they will remain neighbors, but Li will find a new neighbor, Lj will find a new neighbor. So, 2 constant, right. At each event point I am spending constant amount of time to search or to insert new events. And which events I am inserting or which intersection points I am inserting, if they are actually an intersection, that is on K, right. If I insert, I say that here I will say that Li will intersect with L4, I will check with whether Li intersects with, Lj intersects with L4 or not. Yes, it is. I will put it in the event, right. So, what is the final total number of events, event points? Very good. To n plus k then, and each event point, how much time we are spending? Log n, because I have to insert the line segment. Also, if I have a balanced binary search, I have to switch in the intersection point, I have to switch the location of two line segments, ordering of two line segments, that will take log n time, plus constant. Constant in computer science comes as a free, we do not even care, right. So, overall n log n plus k time. Clear? Please raise your hand if you have any questions. What I am doing? I have a set of n line segments. Yes? Yes. Exactly. While I am inserting, what I am doing is, I am checking, inserting a new line, I am inserting it at a, for example here, I am inserting this L6 where there is I am maintaining a sorted sequence of the line segments. First one is L1, what is the sequence? I have L1, L4, then L3, L2, L5, right. What I am doing? I am inserting L6 between L4 and L3. If I try to find out whether L6 intersect with L1, L4, L3, L2, L5, I will spend n square amount of time. Instead of that, what I am doing? Only with L4, L3, it is not intersecting. What I will do next? Next event points comes here. What will be the order after this? This will be, no, first L1, no, here, this is L1, right? No, at this intersection point. So this is the intersection, right? This is which line? This is L6. Sorry, my bad. L4, L1, L6, sorry. Then what I have? L2, L3, L5, right? Now who are the, so I will check whether L3 intersects with L5 or not, right? So if there is an intersecting point, while inserting while I am switching here. Here there will be switch between L2 and L3. At that point I will find whether L2 intersects with L3 or not. Sorry, this is L4, L4 and this is L2. At this switch, after this switch I know that L2 will become a neighbor of L3. Previously it was not. At this point I will insert this event point. I am calculating the intersection points, whether they intersect or not. If I give two line segments, can you find out whether they intersect or not? Right? You know the intersection point. If they intersect, you know the x axis. Accordingly, I put the event point at that. Right? Yes, sir.
When do we check two lines in a second? When do we actually take the neighbors and check whether it's intersect? When is that event of checking?
While inserting, when the order changes, whenever order changes. When order changes, inserting a new line, intersection of two lines, switch, deletion of a line. When at this point, before this point L3 and L5 are, sorry, L1 and L5 are not neighbors, but after this point they will become neighbors. There is a possibility that they might intersect. So at insert I will check, intersection I will check, deletion I will check. Whenever there is a change in the order, whenever the status changes, I will check. But whenever I check, I will spend constant amount of time. Because I am checking with only two neighbors, right? For two lines, suppose there is an exchange. I know that Li and Lj intersects. Li Lj was neighbor, will remain neighbor, but maybe the lower neighbor may with Li may change and upper layer of Lj may change.
Yeah, the order will change.
Order will change, but constant meaning. So whenever it's constant, I don't care.
So the checking the order whether they are changing will take constant.
Constant, yeah,
See,
yeah.
that line.
Two, I can in constant time I can find out whether two line segments are intersecting or not. That is my basic assumption. Okay. Yes. Okay. No, because in intersection the order will change. For example, no, not necessarily. Why? Okay. Let me give you an example. Here, do we check whether L3 intersect with L1 or not? No. Right? Because L3 and L1 are not neighbors. At this point, L3 is here, L2 is here. If I don't check, the order changes here, and L3 and L1 becomes neighbors at this point. So I have to check at this point whether L3 intersects L1 or not. Right? Otherwise, I will miss the event. The sweep line will not stop at this point.
So whenever there is change of order, immediately I will sort.
I have to sort, but with the immediate neighbors only.
With the immediate.
Bus.
That is the.
That is the trick. That is the only trick that I am using.
And in the meantime, if the endpoints are deleted from the queue.
I will change accordingly. No. Here L3 has intersected with L2, but there is an intersection between L3 and L1. This is a P1. Yes, L1, L2, L3. Yes. Yes. Hmm. Hmm. I will not check whether L2 and L3 will intersect. That is settled. Two lines can intersect at most one point. But how do I know that L3 will intersect L1? No, where is the next event step?
So here L1, L3.
Huh? Here, P2. Okay, very good. Nice question. Okay. Here, what is the neighborhood before this? L1, L2, L3, L4. Here, L1 intersects L3. Here, L4. So when you reach the end point, game is over. How many intersection has happened in between, you don't know. What changed what? You can find out. You see what you have to do, you change the, this was the sequence and this is now the new sequence. So very good idea, that's, I'll keep it as homework. It will take time to find out, you can do that. Why do you take a complicated route when I can stop at these points? I'll not save anything because n log n I have to spend in any way.
We have endpoints, we have all the endpoints, we sorted them, but we don't have all intersection points.
That's why on the go I am generating them, that's why I am only generating those intersection points that will actually take place. I am not considering all the intersection points.
So the case which he is telling that we can just get how many intersection points will be there.
Yes.
We will not getting the actual intersection.
I will not go even into the detail, I will not go even into the argument that whether you can find it or not. This is much simpler and this solves our purpose, right? That's an exercise problem. Okay? We all good? Yes, sir.
So what if the endpoint of one line segment is starting point of another line segment?
Degenerate case. Again, I can rotate the axis to handle all these kind of degenerate cases. What you are thinking that this is your axis, right? Can this be my axis? Rotate in a right amount of angle, you will not have those kind of cases.
So the start point of one is end point of another.
Now they become different. I have rotated the axis, right? Again, let me give you. In which angle I should rotate? Think. What I have told you in the beginning of the lecture, all the easy questions I will answer, right? So, this is the case you are thinking about?
No, no, sir. They are intersecting. Like two edges of a triangle.
Okay. Okay, 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 I understand. You're talking about something like, right? Why do I care? It's okay. This is the event point.
No, sir, but
Two event points are merging.
sir, but we don't know before that event point that another line is not there in the order. After that end point, that line is not there in the order. Previous line. So there is no order.
So there are two things I have to take care. One insert, one delete.
How will you check that point? There is no. They don't come in single order.
So I'll first do insert, then delete. Not delete, then insert. One more thing is that at each endpoint, if you can see, you have the list of endpoints. You can see that there are two endpoints together, right? Tweak the code a little bit. Don't think too much. This is much easier than this case. Right? Yes, sir? Yes. Nope. We will maintain the sorted order in a balanced binary search tree. We will not do sorting. Then checkmate. That if each event point I have to sort, n square log n. That's the trick. Yes, sir?
Sir, I have a question. Can we say easily if there is a n line and none of them are parallel, then there should be an intersection.
No, not necessarily. Who said you that? If there are n lines,
None of them are parallel, there should be intersection.
lines or line segments. If there are n lines, no, not necessarily. Why? Why there?
Parallel line will intersect. He's asking non-parallel lines to intersect.
Yeah, of course. If there are two lines are non-parallel, they will intersect.
Yeah, then there should be a intersection of L1, L2 and L3, then we can shift the order
Mhm.
L1, Ln, and then there should be the n adjacent.
Yeah, so there will be n plus k event points. K is the intersection. If there is no intersection, k will be 0. Right? At each event point, I will spend log n amount of time. So n plus 0 into log n is n log n. No, yeah, switching, insertion, deletion, everything. Log n time, because I have to maintain a balanced binary search tree of the intervals, right? According to the order along the sweep line. This one and this one, I am sorting the x coordinate, I know that there are 2 points equal. Right? In the sorted sequence, how many lines will be there? N. I will check whether they intersect or not. I will check separately, do some pre-processing. Checkmate. Right?
So here it is difficult to know.
Why?
If the endpoint points
This is same as this one, x coordinate. I will check the y coordinate, whether y coordinates are same or not. Right?